Hi everyone. My name is Vels, and the name of my presentation is From Wearable to Wearable. When we started this whole story, wearable was just a buzzword, which was kind of hollow to me. And the second wearable is something that you can actually wear. So this will be a short story from the trenches about developing the product. This product, it's called the KiGo. And well, it basically started with this little girl. This is Nikki. Nikki was 9 years old. And in the spring of 2013, she got lost in a big skiing area in the Alps. Uncle Erik was, of course, very worried. And not only he. Yeah, so your child is lost, what do you do? And that started thinking him like, would it be possible to create a solution? Everybody's talking about wearables. What if we could create a watch that's completely standalone and that can localize itself using GPS, but also Wi-Fi for inside, that you can use everywhere in the world and couple it to the smartphone of the parent. Okay, that's very nice. Then we have this concept, and what do you do? Well, in this case, Erik is now the CEO of our company. Not a technical guy. So what do? You hire a team first. This is us. This is our first office space in a very renowned area in Amsterdam. And yeah, we took some wood, we created a desk, and we started just developing a concept. What can we do to make this real? This is Erik. He's the uncle of Nikki, and he's the CEO. Of course, we have front-end developer, Erik Wijs. We have a designer, graphical designer, Dave. Oscar is a back-end developer. And this guy, he's actually here for the difficult questions today, Cas. Yeah, and just we started working. That's simple as that. And okay, but how do you start? I mean, nobody of us actually created product like this. We all have some experience. We know a little bit programming. But where do you start? Okay, we just started dreaming and we created this first idea. Obviously, it needs to have a form of a wrist. So, yeah, it has to be something round. And it would be nice if you make a watch that also has a display. Yeah, what do we then? Oh, maybe something with a battery. And some modules. We also need electronics, right? So, yeah, then we make nice pictures. And well, maybe this could fit. And you can see here like how it's all curled up around the wrist. And these are all ideas. Oh yeah, then we need some plastic because a PCB alone is not a product. So, okay, some plastics. Looks really nice, but then this is a picture. This is not a product. What did we do? So at this stage, we're talking about 2013. This is the moment Nikki got lost, and we were all during this period. We actually just said like, okay, we need to start somewhere. Let's make the electronics. Let's see if we can do a proof of concept to see if it's actually possible. So yeah, we had many meetings. We scrolled the web, asked our suppliers for, okay, give me the smallest module you have. Yeah, we don't have any money, so please also send some free samples. And finally, we came up with the first working prototype that actually had the form factor of our first initial idea. And it looked like this. So this is the first kids watcher. And I have really strong feelings about this because I worked very long hours to actually make these very exciting digits on the display. But this is the form factor as we envisioned it in the first. This is the heart. I will explain a little bit more about the electronics later, but I want to keep it a high-level story first. But yeah, we have some MCU with Wi-Fi. We have a modem. Oh, also an antenna. Oh, another antenna for the GPS, for the GSM, excuse me. And yeah, okay, we didn't have SIM on chip, so we used some external socket here. And we wanted to do some debugging as well, so yeah. Okay, very nice. And actually, this was the proof of concept for our first presentation. Yeah, we are a young company. We started boot camp here in the building. At that time, they were still located somewhere else. And during our investor meeting, this is what we presented. And then people was like, okay, but this is not a product. Yeah, we know. But we need money. So, but still, we showed them that we were able to build something, although it's not very finished yet, that we were able to build something. So, from schematics and this first form factor proto, we actually had to go to a functional prototype, obviously. And there was a whole different strategy. And the design that we had initially looked very hooky. I have a 3D print of that design with me, and I can show you later after the presentation. But I can tell you it's more something that you find in a planetary institution than that you want to give to your child. So obviously that was not a good idea. So I was back to the drawing board, and we came up with what the first kids watcher. Because we, for this design, actually put the batteries in the bracelet itself, so we could concentrate all electronics in the housing itself. We actually have working prototypes of this. So how does it look inside? This is the whole idea. Like I said, there's a flexible, rigid combination circuit board. There we put on the batteries. And then we have a PCB over here. Oh yeah, there's the display. And then we click the whole thing together with this frame here. And oh yeah, there's the top casing. It sounds very complicated, and it turned out it actually was. And I have a small video that I want to show you. So,
Hi my friends, today we are at FF, we're in the south of Holland. I'm going to show you how we make a first series of kids watchers. FF is specialized in making small series. I'm going to show you. Did you show the design of the kids watcher, or what can you show?
of course, yeah, I was just inspecting the latest mold. Well, the trick is of course that we have the flexible circuit board with the batteries. And finally, we have to mold this. So actually, I'm inspecting now. I'm preparing all the flexible circuit boards so we can make beautiful kids watchers from them.
Okay, let's check it out in the workshop.
So you look at the handwork. The amount of handwork is ridiculous at this stage.
So if we open it here, you can see the kids watcher. It's actually still a bit warm, but we do it on a very cold temperature. Here you see the design of the kids watcher. He just made it. He makes it on a cool temperature. It's actually still a bit warm. Here you see the mold. So this is the outside, and this part, the PCB, will be placed in the middle. This is actually the antenna, what you see. And then we have a working kids watcher.
And then we have a working kids watcher. All right. Well, it became very obvious from this story that this is a nice video of 3 minutes, but the actual production process for this one single KiGo took half a day. So we had a production rate of 2 KiGos per day. Obviously, it's a rapid prototyping company, but yeah, it became very soon very clear that no company is ever going to be able to help us to produce this. Problem are the batteries. It sounds very logic, but if you're in the flow and if you need to, give proof to your investors that you're actually on the right track. So we made the wrong choice here by actually having the idea that we could injection mold with the batteries already inside of the mold, and that was wrong. So what do you do then? You travel around the world, you look for partners, you go everywhere, and then this part, especially the question mark, was really a blocker. At this point, we did not sure what to do exactly. So we started looking for more strategic partners, people who had more experience with producing child products or similar toys. And then we ended up in places like this. Well, this piece of metal is kind of typical, recognizable. Yeah, this was just a fun. We had many presentations, but even then we did not find the right partner. And the second thing is that we learned here is that we had to go all the way back to the drawing board. We already had a discussion that 2G is being phased out in many countries. I heard about Australia, but we had the same experience already in the US. And our first product was completely based on 2.5G. So that means that's a no-go. If you want to make a watch that you can use anywhere in the world, then definitely you need 3G. So there was a big setback. We still had this issue with the batteries, which we could not hot injection mold, and this was a big setback. But fortunately, we found another partner here in an engineering company, and together with a new hire we got, Jesper. He's an industrial designer, and they just redesigned the whole KiGo, as we call it, and they came up with this. And this looks very similar to this one. Instead of trying to do all kinds of batteries in injection mold, we have now a hard casing here at the bottom. And in that casing is the battery, completely shielded and protected for the children. On the outside is the actual 3G GSM quad-band antenna. Well, with the benefit that also the battery is damping a little bit, so that saves a little bit of radiation to the child. Here we have the PCB. That's not that different from the other one, but a very important difference is that we have a color LCD here. The OLED technology was advancing that rapid that it would, after a year, because we started out, we could get a very good quality OLED screen that actually fit into our design. And we were very happy with that because it offers a lot of more capabilities for the UI design. Here are the buttons. This is the next button and the action button, as we call them. And the whole thing is also protected by Gorilla Glass, which makes it splinter-proof and also a little bit scratch-resistant. After all, it was designed for children. So, time-wise, we're already in 2016 now. We had a functional prototype. Yeah, but then we still need to sell them to customers for somehow. So one of our investors is actually from Hong Kong, and he advised us a very good contact over there. It was a small engineering company, but they're really good in doing interviews with potential production partners. And they've helped us to select a good partner in Xiamen in the end. Xiamen is on the other side of the Yellow Sea of Taiwan. And we found a company called Hybit there. And they did not have too much experience with wearables themselves, but they had a very good molding partner. And they said, like, okay, we don't know exactly how to do, but we will grow with you and we will co-develop. When we could have gone to a big company who already did the Nike Fuel Band, etc. But first, you need a big bag of money, and we didn't have that. And second, you don't get attention because, with our budget, we can order thousands. And then they say, like, well, maybe we have some time left after the cigarette break. So, no, we needed a company that needed to grow with us, and we're very happy with them. And during the Q2 in Q3, we worked very hard. And right now, this is us selling the KiGos to the first happy customers. But we're a technical group, so now we can talk technique. How does the KiGo work? Here is the watch. And as I already said earlier, like it uses 2G, 3G. I'm sorry, there's a little bit wrong with the contrast. I hope everybody can see the colors. Yeah, it's good visible? Okay. The watch itself communicates through a private APN. We have a deal with Vodafone, who actually offers us a corporate GPS network. And, not necessarily, but it makes it a little bit easier for us to control who's ever using the SIM on chip, etc. I just heard that even 4G can be completely fully monitored, so the idea of having extra security with that, I'm not going to mention that here. We did for somehow, we have that. And we talk with IP in a normal way. but also because we want to be reliable and busy day on the beach. Obviously, data connection is not always possible. If you've been Koninginnedag here in Amsterdam, well, not always. So we have a fallback protocol, completely based on SMS. And through the network, we talk with this server here. We call it the relay center. And the relay center is just the one that interfaces with the whole fleet of KiGos. On the other hand, we have the smartphone application, which uses the normal regular internet to talk with the service center, which is the gateway to all smartphone applications. And together they define the protocol. It's not very interesting to go into the details here, but if you like, you can address me or Cas after this presentation. So hardware-wise, after the first design, not much changed actually, and the whole idea of the Kids Watcher is based on this module here. It's a module from Murata, and that offers the big advantage. It's actually a system on module. It offers an STM32 M3 Cortex microcontroller, but in the same housing also a Broadcom Wi-Fi solution on a very, very small form factor, which was exactly what we needed for a small watch. And on the second, we have here the module from Sharrow Wireless. First thing we noticed, like coming from 2.5G with an acceptable size for the modem, was like 3G is also big. So yeah, we had a lot of trouble actually redesigning our hardware around this module here. But yeah, it's a 3G model. It's the smallest we could find at that time that fitted our bill. And as a bonus, it also has a Surstar GPS module inside. So this is these together are almost a complete Kids Watcher. KiGo, sorry. You notice that I sometimes say Kids Watcher, sometimes I say KiGo. For years we called it the Kids Watcher, but yeah, then we needed to rebrand it because it was not original enough. So now it's KiGo. But somehow that keeps sticking in my head. Probably will live forever. So yeah, we have the modules here, but obviously you need a little bit more. We need to charge it. There's a battery logo here, not very good visible, unfortunately. LiPo charger, so we can charge it over USB. This is a USB cable. Many parents actually said, like, okay, that's very nice. You know where the watch is, but where's my kid? How do you know that's being worn? So we have an on-off detection on the watch. And the KiGo actually generates an event to the back office whenever the KiGo is put on or when it's taken off. And it's not a protection against things like kidnapping, etc., but at least it's some form of extra security. So we do that with an infrared on-off detector. It's a regular proximity sensor, and I think most smartphones have one these days. Then we have the 16-bit color OLED. Well, the previous design had only one color, which means that it's 1 bit per pixel. We have a very small RAM, 128 kilobytes, still twice as much as Marcel talked about. Yeah. But yeah, obviously you needed extra storage, and we found it in the form of a Spinor flash chip that we integrated on our design. And we also have a motion sensor. But you have it turned off now, but normally if you shake it, then the backlight turns on so that you can see how late it is, what time it is, and yeah, just features. Please interrupt me if you have any questions.
Is there a SIM card in this device?
Yeah, I did not draw it. Yeah, we have a SIM on chip, so it's not a SIM card. It's a SIM on chip that's actually soldered on during the PCBA assembly. So you cannot use your own SIM on this product. We have a subscription for the SIM on chip, yeah, but you need a subscription with us. Yeah, that's for sure.
Does it also work in the Alps?
Yeah. I didn't test it myself, but yeah, I think if you have a normal connection with your cell phone, then this product will also work. Of course, there are always exceptions, but.
Of course, the GNSS reception in the Alps will be quite impaired, so it can be hundreds of meters off.
Yeah, well, the big advantage of using Wi-Fi and GPS is that together you can usually find a very good combination. I mean, in rural areas, Wi-Fi tends to be much more secure. accurate, reliable. Thank you. Well within 15 to 20 meters usually. And well, if you're outside, then you obviously usually have also an open sky. And with our
Indeed, in lots of spaces you have open sky.
yeah.
But in the mountains, was the question, you have reflections from the mountains themselves.
Yeah.
And also the mountains block the view to the satellites, so you can be quite a long distance off.
Okay. Well, if you say so, I don't believe it, but.
Oh, you don't believe it? Okay, we'll talk later.
Well, I don't believe it in the sense that
Fine.
I don't need to pinpoint the watch within 5 meters. Over 5 meters is very acceptable. I mean, I don't need sub-meter accuracy, right? So unless you're really down in the gulls, then yeah, debatable. I don't know. More questions on this? Okay, then the next slide tells us a little bit about the architecture. Sorry for the rather boring picture, but I still wanted to have it. Here on the bottom is the Cortex hardware itself. Our firmware is based on just a regular free RTOS kernel. You can download it for free. It's a preemptive kernel which has some nice synchronization solutions like mutexes. Very simple. Yeah, to actually talk to the Wi-Fi solution from Broadcom, we use the Wicked library. That's also an SDK you can download for free. And but we integrated it into our own firmware stack. Obviously, the system on chip from STM has some standard peripheral libraries, also downloadable for free. And mostly because we have a dependency by the Wicked library, we also integrated part of the lightweight IP stack. We use the IP stack of the internal IP stack of the modem. But one very handy feature we found here was the shared buffer provisions, like the pbuff. Yeah, sorry, but we wrote the whole thing in C, and we also took the classic approach. Yeah. Every task has just a queue, get messages, one single state machine, single threaded, and to deal with everything. And the blocks here are actually the drivers. We have one for the hardware, which means like handle the buttons, handle the buzzer. We have one for the Wi-Fi. Obviously, we also need to draw pictures on the screen, and we need to talk with the modem. So these are all dependent on the hardware, and yeah, I was about till later. We also have an alternative implementation for these, so that we can simulate the whole thing on a PC. And here on top are the modules like the communication module. We also have something that most people would like to call the watch manager, but we we called it the final state machine in the hope that it would be the last one. But so this is a generic part. So this communication, well, people like protocol stacks. So imagine that I want to generate an alarm. Yeah, I'm in need of help, and I want to signal to my father that he needs to come and help me. I have a flat tire in the middle of the nowhere. I don't know. So I press the button. Then the KiGo needs to send out a message, and the first thing it does is collect all the data for the message. And using the protobuf protocol, it assembles a message. Protobuf is provided by Google, and they use that to stream large amounts of binary data internal between their servers. So it means it has a very little overhead. It does run length encoding. So if you keep your integers small, the overhead is even less. And it's also for free. It has a big advantage that once you have the formal model, you can also generate marshalling and unmarshalling classes over your Java and Python side, which was also attractive for us. So that's the first step. Then we assemble this into what we call an application protocol data unit. Not very simple. It has a header because if you have this data, you need to know what's inside. So we have a small identifier saying like, hey, this is this kind of data contained in the protobuf messages. Obviously, for security reasons, we don't want anyone to to know what's going on. Maybe it's a simple message like I need help, but could also be alarm. It can be a location request. People are, it's very clear that this is sensitive information. So this whole application protocol data unit is then encrypted and then embedded into a transport protocol data unit. We deliberately designed this one such that it can also be fragmented. So in the case that we need to communicate over SMS, we can generate multiple small transport protocol data units so we can tunnel it over the SMS. A lot of features are actually, we didn't have the watch at the beginning because we didn't have real hardware, but still we wanted to have a simulation of it. So really, really early on, we already implemented the Kids Watcher simulator. We wrote these network-specific tasks, and we wrote them again for the PC. We found a free AirTOS simulation running on top of pthreads, which was good enough. It didn't sound very real-time, but then again, we don't need real-time, we just want preemptive. And it gave us the opportunity to have all the application logic from the generic compiled for PC. And using that, we built our test environment. This is the whole simulator. And for testing side, we use Python because there are many people who know Python and we like Python. So we have here the Kids Watcher protocol that I just explained a little bit earlier. Just testing Happy Flow is a little bit boring and not very a good thing. So we also needed to inject errors and scan results, etc., etc. So we built a small JSON RPC-based interface so we could, from the script, actually tell what's going on, generate an error. These are your scan results, overflow, so we can generate the diverse error conditions. After a journey of three years, what did we learn? Well, as I already said a little bit, investors only believe you when you can give them something to play with. In the beginning, we had a very, very, very hard time in convincing investors to go. Excuse me. We had a very hard time convincing investors that we could actually make this watch and go to market with it. And that's one of the things that lessons learned. 2015 was a very weird year for us. We also had an extra guy helping out with the firmware. We had a lot of changes in the design from the UI, etc., etc. And at some point, we accepted slippage in the code coverage. We always started out with doing real test-driven development. Write a module test, do your thing, and then run the test until it works, and then in that order. And at some point, we really got under so much pressure, and that we let that slip. And that means that we do have to do a lot of manual regression testing, and that's a bummer because that takes a lot of time. And we could have done a lot better things than pressing buttons. But that's how life is now. Not everything, but quite a lot. One other thing is automated hardware testing. The testing framework I presented you on the previous slide is obviously all software and simulated. And simulation is never, ever, ever 100% representable for what's actually going on. So it's very high on my wish list to actually have some piece of hardware that we can use to fully test the KiGo and to do remote updates and then not just one time but 100 times, etc., etc. So that was my part. That was my story. Thank you for your attention. And if you would like to know more about KiGo, you can use this QR code, and it goes to the general website, not just a web shop. So, thank you. Yeah,
So
questions?
the battery is blocking the 3G module a bit for the radiation to the wrist. Is there any legislation requirement in terms of reducing output power when you're close to a wrist? So, for example, the mobile phone, you have to do this, right? So legislation says if you have it close to your head, you have to turn down the output power, at least in that direction.
Yeah.
So is it so similar with any other body part like a wrist?
No, it's similar. I don't think if you do the regular testing, then there's a specific absorption rate. That's the test you refer to. That's the amount of power that's being absorbed by the human body.
Yeah.
And yeah, we verified that during our testing, and it was within the limits. But I don't think there's difference between which body part.
Okay, so it would be the same as.
Yeah. Anyone else?
Where are they for sale for?
Sorry?
Where are they on sale? Or are they not on sale yet?
Yeah, they are on sale. If you follow this queue.
Yeah, so what's the price?
Are you looking at any deals at all with like Coolblue and Amazon and stocking them in places like that?
Right now it's on our own web shop. There are some things, I can't disclose that yet because the deal's not finished yet, but I don't think we're really too much into big channels because, how would I say it? Then we also need a good customer support, second line support, etc., etc. And we're growing as we go. And we're only with 15 people right now, so we're really small. And I think if we go with that big customers, then it might be too much at once. But obviously, we can have a short chat and see if there's a.
How much investor money have you had?
I would estimate. I'm not sure. I didn't do the calculation, but I said 1.5 million.
To one person or group?
No, to multiple persons. We also did some crowdfunding. We did 3 crowdfunding campaigns on Simbit, and so there might be a shareholder in the audience.
The product is now live. During the presentation, I can imagine I already have new ideas. Are there any upgrades already planned within the company? For example, talking from the smartphone to the watch. Stay still, don't move.
No. Well, I didn't go too much into the features of the product. Maybe I should have done a little bit more. But it's possible to communicate using icons. So, for example, you as a parent want to say like, it's time to come home. So you can send an icon with a pen and, oh, sorry, it's something with my voice. I think so. And a cigarette probably also. So on the watch then you see this image and you can reply back with another icon saying like, I'm coming home, or a question mark like, sorry, I'm busy. So you already have that communication. But we really decided against having a voice connection because, well, on one hand, it makes things a lot more difficult to make it waterproof. You can actually swim and you jump in the ocean with this watch, and that's it. Obviously, if you go too deep, there's no GSM connection anymore. But yeah, you can wear it on the beach. That's the point. Okay. And that was for us far more important. We thought also for our customers to not have voice connection.
What does it cost?
189 euros.
Okay, the app is free software?
The app is free. You can already download it. Yeah. Sorry?
No, that's good. So for how many years is that?
For as long as you like.
And then the 3G subscription is on.
You pay, that's the subscription part, is 6 euros per month for the whole of Europe and 8 euros for worldwide.
Okay. And what is the battery lifetime?
Well, that's very dependent on where you are. If you're in a basement in a very outside area, then the KiGo needs a lot of transmitting power to actually keep contact with the base station. And in that case, it can already be done within 8 hours that you run out of batteries. But in normal situations, 16 to 18 hours is.
Did you keep GPS powered always then?
No.
Okay.
No, we use assisted GPS. So usually we get a good fix within 5 to 10 seconds. When it is good enough, so we don't need to keep it powered on.
Do you push system updates over 3G automatically, or is it something that customers need to do?
No, we do that. Okay. We use our own system, our KiGo protocol, to download over-the-air updates.
Without question?
Without questions. But it only happens at night when it's on the charger. So we check when we're doing the download, it's actually on the charger and not being used at the moment. Blah, blah, blah. So, yeah. Also for power consumption. Yes?
Am I right to assume that you also have indoor locationing with the VC?
Yeah, well, not within the house. But if you look, for example, to your smartphone, it also uses a lot of Wi-Fi signals. We only scan passively for MAC addresses.
Yeah, you feed that to Google and...
Exactly.
So,
That's exactly right.
Are you sourcing Google for this or another party?
Google.
API for
Yeah, it's really, and we're also experimenting with some other partners, but Google is the main. I was actually quite surprised and funny when you show in your presentation you had a picture of China. Well, obviously Google Maps does not work in China. Something, huh?
Google Earth works.
Yeah, but yeah, we didn't integrate it into our Looks app. So yeah, please visit our website. There's a lot more. There's also some explanations on the smartphone app. If you any more questions?
Did you do any able to protect this idea or this product, or is it just like we're the first and if somebody copies it, we're the best, or how do you?
Yeah, well, it's a little bit more like that because we were very low on cash and we decided to spend it on development instead of trying to protect it because yeah, obviously that would cost a considerable amount of budget.
So now you need to grow.
Yeah, now we need to grow. Thank you.